Fire has brought a lot of destruction throughout human history. It has always been there as a destructive force. In some cases, that has had a very consequential impact, leading to the end of an era. And for instance, if we can mention the Hindenburg airship fire in 1937, which was a tragedy occurring in New Jersey, and it led to the end of this economic I would say it led to the end of the airship era and this economic sector. So today, as we are looking at new construction and new structures, in terms of the techniques that we can employ to make those structures resilient to fire. First of all, there are now building codes in application that aim to guarantee a certain level of fire safety and that engineers have to comply with, which were not, of course, in application at the time of cathedral building. But further, we are working to better understand how fire can develop, grow and spread, as well as how materials and structures react to the heating generated by the fire, because it's really the heat that challenges the structure for any material, really. And so the goal is to enable engineers to make the best use of materials and structural layouts and design to ensure the fire endurance in case of fire. So we are working, for instance, on numerical modeling techniques and software, such as we have a software here called Sapphire, which is a finite element software that aims to predict how a structure would deflect and react and be challenged by the heat generated by a fire. And if we have this predicting capability, then really we can optimize the use of materials and the structural design to endure the fire hazard.